Gas laws. So for this unit, we need to start off with a really good investigation of what temperature is all about, because temperature is really important for gases. So thinking back to last unit with the states of matter, we kind of already know some of this. So I'm just going to show you the old notes. So temperature is, of course, the average kinetic energy of all the particles in a sample, and it's measured frequently in degrees Celsius, but sometimes also in Kelvin. Okay, so K is for Kelvin. We're going to come back to that one in just a second. It does not have a degree sign. There's a reason for that. Heat is the actual energy in the substance, and that's measured in joules, which we don't really have to worry about as much for here. But heat and temperature are not the same thing. Heat is what causes the kinetic energy of all of the molecules moving. Temperature is sort of a measurement of the average movement. So some particles are moving faster than others, but on average, they're moving a certain speed. If you start increasing the temperature, the more molecules will be moving faster, but they're still an array. So generally speaking, we use the Celsius or Fahrenheit scale in our lives. As Americans, we use Fahrenheit because we're ridiculous. And most of the rest of the world uses Celsius to measure like temperature of a person or of your baking temperatures, your cooking temperatures, or weather. And a lot of times we use Celsius in science, in chemistry, but sometimes we also use the Kelvin scale. So Kelvin is an absolute temperature scale. Celsius is based off of the boiling point and freezing point of water. The boiling point, of course, being 100 degrees Celsius and the freezing point, of course, being 0 degrees Celsius. But the Kelvin scale is 0 is defined as absolute zero, absolute complete lack of molecular motion. So there is nothing that's lower than 0 Kelvin. 0 Kelvin doesn't even really exist. Not exactly. It's very difficult to achieve. We as in labs, we as human beings have created substances that are pretty gosh darn close, but not quite there, because having no molecular motion is really practically impossible. So there's no negative numbers in Kelvin, and it's also there's no degrees because it's an absolute scale. So Celsius, you put these little degree signs. Kelvin, you don't. The conversion between the two is pretty simple. This is the equation here. Kelvin is equal to the degrees Celsius plus 273. So if we have, gave us like two different things to convert. So I want to convert this one to degrees Celsius, and I want to convert this one to Kelvin. Again, no degree sign. So we just need to do that. So if we are given Kelvin, we're trying to solve for Celsius. So we're going to need to rearrange this equation just a little bit. Degrees Celsius is going to be Kelvin minus 273. Pretty straightforward. Let me see if I do have a calculator over here. We can use that. Very simple. Very, very simple. So 350 minus 273. Yep, that's right. Oops, there we go. Is 77 degrees Celsius. Okay, that's pretty hot. In Fahrenheit, what would that be? That would be something like 200, in the 200-ish kind of range. So pretty hot, being that like 25 is about room temperature. 42 degrees Celsius, about 100 degrees Fahrenheit. I know that because when I would go to foreign countries and I have to tell people how hot it got in Tucson, I had to remember what that was. I'm like, oh yeah, like 42, maybe 43 is our highs in the summer. And they'd be like, whoa, that's hot. I'm like, Anyway, so the conversion is very, very simple. That's pretty much all there is to it. So that was 350 minus 273 equals 77. Okay. If we need to do the reverse, if we're trying to solve for Kelvin, this equation will work just fine. So we have K is equal to the degrees C plus 273. So that's going to be 350 plus 273. So 350 degrees Kelvin is pretty hot. It's definitely like hotter than you would set your oven. Like 350 degrees is kind of standard for baking for Fahrenheit, but not for Celsius. For Celsius, it's like, I think like around 200-ish, something like that. There's an equation for it, but it's kind of annoying. So I don't really see any reason to do it. And it doesn't come up too often. And you can just look it up. Not a big deal. Okay, so this one's 623 Kelvin is our answer. All right. That's pretty much all there is to it. In terms of Kelvin, I have a whole bunch of videos. I'll show you this on my YouTube channel. On the gas laws unit, there's a whole bunch of videos here. 1, 2, 3, 4, 5, 6, 7. There's like 7 different videos that are all about both Kelvin and temperature and like what's with Fahrenheit and what's with Celsius and some thermometer kind of stuff. It's pretty cool. Definitely worth checking out. We'll watch at least one of these in class, I'm sure. Probably the first one. The TED Ed ones are always good. Back to this though. Okay. For you all, the unit packet that you need to work on, the unit packet pages, is just going to be page 1 of the Unit 9 packet. So this is just converting between Celsius and Fahrenheit. And we've got all the equations right up here. So it should be pretty straightforward for you all. Let's do like one of them for funsies. Let me pick out a good one. Celsius. Then let's do Kelvin to Fahrenheit, just because that's probably the trickiest one of the lot. So if we have Kelvin to Fahrenheit, I think what we're going to need to do is we're going to need to go Kelvin to Celsius, and then we can go from Celsius to Fahrenheit. Those are going to be kind of the ways to do that. So if we have, if we have Kelvin and we want Celsius, we've got a little formula up here, pretty straightforward. That's going to be, so Celsius is equal to Kelvin minus 273. So we have 383 minus 273. And I think that's going to be, I don't know. I'm just going to put it in my calculator, even though I should be able to do this one in my head because, yeah, 110. Okay. So that's 110 degrees Celsius. Now we need to go from Celsius to Fahrenheit. We'll use this equation because we want Fahrenheit and we have Celsius. So that's going to be Fahrenheit is equal to Celsius times 9/5 plus 32. So that is going to be 110 Celsius times 9/5 plus 32. There's actually if you should ask me in class at some point, or I can give you the idea here. There's a way to derive this formula. You just have to know about slopes of lines, equations for the slope of a line. It's actually pretty straightforward. So I've never memorized this formula ever in my life. If for some reason I have to convert and I don't have like the internet to help me, I will just derive the equation. It takes a few minutes, but it's not that big a deal. And I can just derive that equation and figure it out. It's it's actually not that hard. Okay, so 110 times 9 divided by 5 plus 32 equals 230 degrees Fahrenheit. So there you go. That's how you do it. You are going to need to, I don't really care about Fahrenheit. Frankly, it means nothing to me. So these problems, number 5, it's cool. Give it a try. It's not a big deal. But 1, 2, 3, and 4, you just have to be able to do those, just like lickety split, because you're going to have to use Kelvin for gas laws. You don't always have to use Kelvin. Sometimes you can use Celsius. It just kind of depends on the formulas, but that's what's going to happen. So next set of notes, we will go through more about gases, and we will know all this cool stuff about Fahrenheit or not Fahrenheit, but temperature, Kelvin, Celsius, and all that loveliness. And there you go. Thank you all.